Okay, we're going to work a scenario for using inverse norm. So using the inverse norm of the calculator. So a packing machine is set to fill a cardboard box with a mean of 16.2 ounces of cereal. So we know that our mean is 16.2. This is important. Suppose the amounts per box form a normal distribution. Oh, good. We need that so that we can use the normal part with a standard deviation equal to 0.1. All right. What percentage of the boxes will end up with at least 1 pound of cereal? Notice this is in pounds, this is in ounces, and I need to know that 1 pound is equal to 16 ounces. All right. So I'm going to go ahead and start off by my general situation of, hey, draw the picture and see what you have. So what I have is this. I have a mean of 16.2. So this is what we start with. U is 16.2. And they say with a standard deviation equal to 0.1. And they want to know what percentage of the boxes will end up with at least 1 pound. All right, so at least 1 pound. So that means right here, this is 16. So I'm shading up. Now, I need the probability that X is greater than 16. Well, anytime we're working with normal, I really write down Z equals X minus mu over sigma, and I start plugging in. So the probability that Z, looking for a greater than 16 minus the average of 16.2 divided by my standard deviation of 0.1. Well, the question is, am I using an inverse norm or norm CDF? Well, since I have everything, and since it says I'm looking for the percentage, it says what percentage? It says what percentage, that means I'm going to use a norm CDF. If they give me the percentage, I'm doing an inverse norm, but if they ask me for it, I'm doing a norm CDF. So I need to go to the norm CDF part of the calculator. And actually, because I'm only shading one direction, since I'm only shading one direction, I'm going to use the z-test. So second vars, stat test z-test. And I'm doing that because I need to have that z-score. So stats test z-test, my mean is 16.2. My standard deviation is 0.1. My X is 16. And it says, and I'm working with a sample size 1. I shade it up. Oops. Went too fast. And I end up getting Z equals -2. So the probability that Z is greater than -2 equals 0.9772. So 97.2% of the boxes. Now, if I'd done this normal CDF, second vars, normal CDF. Now, keeping in mind, I need to go ahead and calculate what that is. So let's go back and calculate my Z-score. So 16 minus 16.2 divided by 0.1. And I get a negative Z-score, which I've already written down. So that's a -2, and I can go second vars, normal CDF, and I can use the 16. Upper bound goes to positive infinity, mean is 0, standard deviation of 1. And somehow or another, I did that incorrectly. Second vars, normal CDF, 16.2 for my mean, and my standard deviation is 0.1. There we go. We get the same value. All right. So you could have done it with the z-test or the normal CDF. The thing is, you have to give that z-score. You got to give the z-score. They're very picky about that. You don't want to lose half credit for not having the z-score. All right. 10% of the boxes will contain less than what number? Here they gave me a percent. If they give me the percent, I'm going to be working with a, I'll be working with an inverse norm. All right, so first off, they say 10%. Well, as soon as they say will be less than what number? I don't know what number is, so I'm going to say, okay, X. But 10% or less is like, oh, that means it's over here. So what the X is above it, because 10% is less than this number. Draw it like that. It'll help you out a whole lot, because this is a confusing way to ask the question. It's not a hard computation, but 10% are less than that. So always put the X and then go where, just determine if it's 10% is above, you put it above. If it's below, below. So in this case, we know we're dealing with our mean of 16.2. We have our standard deviation is still 0.1, and we're looking for below. So this is that value right there. So once again, Z equals X minus mu over sigma. And I start plugging in what I have. Well, what I have is 16.2. We know that this is 0.1. Oh, we're looking for that X, so that goes there. And I need to find that Z. So I need to calculate that Z. So I'm going to go back and calculate the Z because College Board's requiring it. So this is an area of 0.1, and Z score is mean of 0, standard deviation of 1, and we get negative 1.28. At that point, I can go back and re-enter the inverse norm. So first off, I did it like this: inverse norm, area is 0.1, mean of 0, standard deviation of 1. All right. Then I go second vars, inverse norm, and I'm going to actually use the actual values. And the actual values are the area is 0.1. That's what I'm interested in. I have a mean of 16.2, and I have the standard deviation of 0.1. And I end up going, my X value that's right here is 16.07. And that makes sense because I have it shaded below, so it definitely needs to be below halfway. So X equals 16.07. Once again, I'm just telling you, the graphs tend to help out a lot. Always show, but this right here is 100% required. But I recommend showing a picture. It's worth the extra 30 seconds it takes. 80% of the boxes will contain more. Okay, so I have an X and it says 80% or more, so 80% would have to be above it, just like this. So that means I'm shading this way. This is 0.80. Our mean is 16.2. So mean is 16.2. Standard deviation is still the 0.1. And I'm looking for this X value. I'm also looking for that Z value. And remember, Z equals X minus mu over sigma. I start plugging in what I have. I have a mean of 16.2. And I have a standard deviation of 0.1. And we're looking for X. But they gave me this. But remember, the calculator works from left to right. So I need this 0.20. So I'm going to do an inverse norm. Second vars, inverse norm of 0.2. Mean is 0. Standard deviation of 1. And I get negative 0.84. Go back, second vars, inverse norm. And I'm going to use the actual values. 16.2, standard deviation of 0.1. And so 16.11 ounces. So 80% of the boxes have at least 16.11 ounces, which is good because they're probably selling them as saying they're 16-ounce boxes. So 80% of them at least have enough. 90% of the boxes will be below. So 90% are below. That means the boxes are below this. I said that wrong. Let's put the X. Oh, 90% has to be below. The 90% has to be below the X. So this needs to be 0.90. This is still 16.2. We're looking for this Z and for this X. Z equals X minus mu over sigma. So when I plug in minus 16.2.1, I'm looking for that X. I do a second VAR's inverse norm. .9 Z-score has a mean of 0, standard deviation of 1. And I get 1.28. Then I can go back and rerun it. Second VAR's inverse norm using the actual value, 16.2, standard deviation of 0.1, and I get 16.328. So this value right here is 16.328, and obviously it needed to be below. It needed to be above the average. Okay, 70% of the boxes are above what weight? So we have X, and this says above. So in this case, sorry for the pause. This is X. This area right here is 0.70. Again, our mean is 16.2. So Z equals X minus mu over sigma. We know our standard, our mean is, this is our mean. Our standard deviation happens to be 0.1. We start plugging in. This is 16.2. This is 0.1. We don't know X. And remember, the calculator is working left to right. So I need that 0.3. So I do a second VAR's inverse norm of 0.3, mean is 0, standard deviation 1. And that gives me a Z-score right there of negative 0.52. Rerun it. Second VAR's inverse norm. 16.2 is the actual value, 0.1. And we find out that we end up getting 16.14. That came straight off the calculator. And last problem, 15% of the boxes are above. So boxes, it's above at 15. That tells me how to go. So this is at 16.2. This is 0.15. Calculator works left to right. So this is 0.85. Z equals X minus mu over sigma. Start plugging in. X minus 16.2 over 0.1. Second VAR's inverse norm. 0.85, mean is 0, standard deviation of 1. And we get 1.03. Second vars, inverse norm, 16.2, standard deviation 0.1. And we find out that this value right here, this X equals 16.303. And let me go back through that real quickly. So second, put that where you can see it. Second vars, inverse norm, 0.85, mean is 16.2, standard deviation 0.1. All right, and really what what it's doing for you is it's solving this algebra. You just went through this and solved for X. And our X value of 16.3 is definitely above. It really, really helps if you'll sit there and go, all right, I'm going to write down the X and go, oh, it's above, so I marked it above. Over here, it was below, so mark it below. Hopefully that helps, and that will conclude this video.